Hi everyone, my name is Suali from the University of Illinois, and we are going to discuss how net energy is changed when dietary fiber increases in diets fed to group-housed pigs. This work was presented in 2026 Midwest meeting. Equipment to determine net energy values of feed ingredients is available only at a few universities in the world, but the University of Illinois recently constructed such a facility. This facility has a capacity to hold the multiple number of pigs depending on size of pigs and is installed with indirect calorimeter chambers that are airtight, which enables us to measure the gas consumption and productions of pigs. In addition, because pigs are group housed, pigs share one feeder and move around, which may impact the energy expenditure. As you can see here in the cartoon, the fecal and urine pans are installed inside the chamber, which enables us to collect feces and urine separately. Therefore, using the system, concentrations of digestible energy, metabolizable energy, and net energy, and digestibility and retention of nitrogen can be determined in the diets fed to pigs on an ad libitum basis. And because the way pigs are housed is similar to the way pigs are housed in commercial settings, this system is believed to generate values that are representative of commercial settings. Developing accurate predictions of net energy values in diets fed to group-housed pigs requires an understanding of how each nutrient class influences energy utilization. Therefore, we conducted a series of experiments to determine net energy and nutrient digestibility in diets containing a wide range of carbohydrates, lipids, and protein, with the ultimate goal of developing new NE system. Among the energy containing nutrients, let's talk about fiber and starch. Starch is a highly digestible carbohydrate source, whereas fiber is associated with lower digestibility and increased energy losses in feces, urine, or thermal heat. Fiber provides approximately zero point 0.6 to 2 kcal per gram depending on its structure and fermentability. The respiratory quotient, or RQ, is lower than that of starch, but similar to that of fat because fiber fermentation produces short-chain fatty acids. Therefore, the hypothesis was that increasing dietary fiber reduces net energy and nitrogen balance and the digestibility of nutrients and energy. There were 6 experimental diets. In this experiment, soybean hulls were used as the fiber source to create diets with increasing fiber concentrations. The first diet contained corn and soybean meal without any soybean hulls. The other 5 diets contained corn, soybean meal, and increasing levels of soybean hulls from 6 to 30% at the expense of corn and soybean meal. Therefore, the inclusion rates were 6, 12, 18, 24, and 30%. The ratio between digestible amino acids and metabolizable energy met or exceeded the recommended ratio in NRC 2012. Because corn and soybean meal contain less fiber than soybean hulls, dietary fiber concentrations were expected to increase across the diet. Calculated total dietary fiber increased from approximately 12% in the first diet to 27% in the last diet, and analyzed values closely agreed with the calculated values. We used 2 groups of 24 pigs, and 4 pigs were housed in a chamber. Within each group, the 6 chambers were allotted to 6 treatments using a 6 by 3 incomplete Latin square design, resulting in 3 replicates per treatment within each group. Because 2 groups were used, each treatment had a total of 6 replicates. Pigs had ad libitum access to feeds and water. After 7 days of adaptation, feces and urine were collected for 6 days using the time-to-time procedure. During the collection period, consumption of oxygen and productions of carbon dioxide and methane were also measured to determine the total heat production. Diet and fecal samples were analyzed for dry matter, gross energy, and nitrogen. Urine samples were analyzed for gross energy and nitrogen. Using the analyzed values and weights of feces and urine, the apparent thoracic digestibility, ATDD, of nitrogen and energy and retention of nitrogen were calculated. Concentrations of digestible, metabolizable, and net energy were also calculated. The statistical model included diet as fixed variable and group, period, and chamber as random variables. Contrast coefficients were used to determine linear and quadratic effects of increasing fiber. Significance was set at p-value less than 0.05, and trends were considered at p-value less than or equal to 0.10. Moving to the result, let me first set up the slide. The soybean hull inclusion rates are shown at the bottom, ranging from 0 to 30%, and are presented by different shades of blue in the bars of the graph. All data are presented on a per pig basis. The results indicated that the feed intake of pigs was not affected by dietary treatment. Weight of oats and dried fecal weight linearly increased as soybean hulls increased from 0 to 30% in the diet. The weight of oats was used to correct the feed intake of pigs. Because fecal weight increased, the apparent thoracic digestibility of dry matter and gross energy decreased linearly. The same pattern was observed for the apparent thoracic digestibility of nitrogen. However, retention of nitrogen, which were calculated as a percent of intake or absorbed nitrogen, was not affected by dietary treatments. As a result of the reduced energy digestibility shown in the previous slide, concentrations of digestible energy decreased linearly as soybean hulls increased in the diet. Urine energy excretion tended to decrease, and concentrations of metabolizable energy linearly decreased as dietary fiber increased in the diet. Respiratory quotient, RQ, was calculated as the ratio of carbon dioxide production to oxygen consumption. Results indicated that RQ decreased linearly as dietary fiber increased, and the inclusion rate of corn and soybean meal decreased, which indicated a shift away from starch or protein oxidations and toward greater utilization of fiber-derived substrates in the body. Total heat production and heat increment were not affected by dietary treatments, and net energy decreased linearly as dietary fiber increased. Results from this experiment indicated that the difference among dietary treatments was greatest for fecal energy loss, followed by urinary energy loss and heat increment. This implies that differences in digestibility and digestible energy explain most of the variation observed among dietary treatments, whereas comparatively smaller differences were associated with urine energy loss and heat increment. We also conducted another experiment to determine the apparent ileal digestibility, AID, of dry matter, starch, fat, and amino acids to demonstrate the relationship between NE and nutrient digestibility in the same diets. Data indicated that the AID of dry matter decreased linearly, but the AID of starch tended to increase as soybean hulls increased in the diet. There was a quadratic effect of increasing soybean hulls on the AID of fat. It is possible that the reduction in the AID of fat and the increase in the AID of starch in the high fiber diet were related to increased fermentation and synthesis of microbial fat in the small intestines. But additional research is needed to confirm this hypothesis. The standardized ileal digestibility SID of amino acids were decreased by increasing fiber. The observed decrease in digestibility of a dry matter, gross energy, nitrogen, and amino acids, and concentrations of a net energy with increasing dietary fiber aligned with previous data. The observation that net energy was reduced with increased dietary fiber also agreed with the understanding that diets with high fiber have reduced energy utilization. Using data generated from the indirect calorimeter at the University of Illinois, a new ANI system will be developed in the near future. Thank you for listening to my presentation, and I would like to acknowledge everyone from Dr. Stein's lab. If you want to learn more about our research that we are conducting in Stein Monogastric Nutrition Laboratory, please visit our website. Thank you.